The following content has been provided by RWTH Aachen University.
Good morning, everybody, and welcome to DIS1 this morning. We're going to kick off things as usual with a quick review, and then we're going to launch into more topics that are taken straight from Norman's book, Design of Everyday Things, that we're just going to extend a little on and try to explain in our own words. So first of all, we covered last time the 7 stages of action. So let's see here. What is it that the 7 stages of action model is actually modeling? You can raise your little blue hand if you want. Jona Recker, what do you think? What are those 7 stages of action?
No, I'm there. They are to explain the way from setting a goal to achieve the goal and compare if you really achieved the goal. So for us, it's more about what could be an fault or an error if we design a product, if we go through the steps and look to our product.
Exactly. So you actually already answered the second question as well. Yeah, that's right. That's sort of the idea of why we're doing this model. Remember, it's an engineering model, right? So it's a model that is actually not trying to replicate reality in sort of any biological way, of course, but it's again like the CMN model. It's good enough to do some estimates and help us design better systems. All right. So we talked about this at length, went through the stages, and talked about the gulfs that can appear that we need to bridge for the user so that they don't run into problems using a product. And we'll actually get back to this later today. Next up, we had mappings. We talked about mappings in general, and we talked in particular about natural mappings. And there were a couple different types of these. So anybody want to take a stab at explaining what mappings and natural mappings are? Without looking at your notes, of course. This is supposed to jog your memory, right? Not to jog your reading skills. Alvina, go ahead.
Yeah, for the mapping is basically the relationship between the controls and the results.
Okay, exactly. And if it's a natural one, do you want to take a stab at that as well? What does natural mean? What do you have maybe an example?
Basically, not exactly the definition, but I remember you mentioned that good mappings are the natural mappings, and there were different types like spatial analogies, I guess, and it was like how we basically arrange the things, and then it was perceptual analogy, in which basically the UI is an imitation of the device.
That's right. Yep. Yeah. Those were two prominent examples. We had a couple more, cultural ones and biological mappings. Those were all examples of natural mappings. Very good. All right. And then we went on to constraints and how constraints differ from affordances. And we also looked at a couple different types here. So again, I'm going to, Fabian, want to go ahead and take a stab at those? Reinhard?
Yeah, sure. Can you hear me?
Yep.
So constraints are basically like kind of like limitations. They are forcing you to do something, but most likely in a kind way. For example, physical constraints are like constraints of things you can't physically do. There are cultural constraints, which are constraints that are put on you by culture, so it does not feel right to do them. And it's different from affordances, since affordances are actively trying to make you do something. So that's the difference.
That's right, exactly. And oftentimes they are actually sort of two sides of the same coin. We talked about lock-ins, lockouts, interlocks. Those are subtle differences that you can, that again, remember, these are not usually mathematical definitions. They are lenses to help you look at a problem and understand what's going on. All right, so today we're going to jump into a continuation of that topic, which is the 3 levels of processing. This was actually something that was first mentioned by Norman in a different book of his, Emotional Design, but it made it back into the 2nd edition of this book here. I really like this model because it gives us an understanding that what we're currently doing, which is essentially traditional usability and good user interface design on sort of this traditional level, this behavioral level, is only one of 3 different levels at which you need to consider the impact of an interactive system on a user. So these 3 levels are first the visceral level, and what that means is sort of like a very basic level of you look at something or you touch something and it just, you know, immediately feels right. Visceral means basically, you know, sort of the flesh, right, of blood and flesh. So it's a very physical response that you have, a bodily reaction, an impulse-driven reflex to something. You know, you look at something and you think like, "Ooh, that's going to be nice," or you handle a certain control, you touch a button and you think, "Ah, that feels like high quality," right? You open a car door and you just get the impression by just handling it, by just touching the materials, "Oh, this seems to be great quality." So you're enjoying that. You are at this point not really sure whether the usability we've talked about so far is going to be good or not, but you have a positive sort of first initial reaction to the thing. You know, this is related to when we say bodily reaction, what we mean are things similar to like vertigo when you're like on a high ledge, or the feeling, you know, when you're basking in the sun and warm, happy. So it's not emotions exactly. It's more like, you know, sort of almost hard-coded responses that our body has to certain central perceptions, right? We're going to see how these 3 play together in a second. The second level is the one that we've talked about mostly so far. It's the level of what you could call classic usability, where you have a system and you are asking yourself, is the system, you know, reacting to me according to my expectations? So this is where we apply the learned responses, so this is called in psychology, which are triggered by any situation that's matching a pattern. So this is not how, you know, a button, for example, it physically feels, whether it feels high quality or not. That would be the visceral level 1, but more by what we associate with it. So it's still subconscious and it still happens very fast. It's at a lower level of emotions, but it is something that is coming out of things that we have learned or that we naturally expect of the world. So examples are when you play a sport or you walk, right? You don't consciously think about every step that you're taking. That just happens automatically. You're running a pattern. And similarly, when you walk up to, you know, a device and it has a big lever that looks like it needs to be, you know, it needs to be pulled, then that's the thing you're going to try first, right? It's the learned response. You see a pattern, lever on a box, that triggers a certain response that is a learned response that you try then. And then if the design is according to those learned responses, it'll work well. So and this applies to any learned habit, right? This is basically any behavioral action is associated with something that you expect the thing to do. And when I say expect, this still has something to do with emotions. Oftentimes, when we start handling an unknown new device, we're trying to use a new app that we've never used, or you're trying to operate a machine in the kitchen that you at a friend's that you don't know. There's this initial sense of uncertainty, right? You hope that you're getting this thing right and that you're pressing the right buttons and you interpret the interface right, or you fear that you might break something, right? So this will largely depend on things that we've already discussed, like visibility and feedback, of course. And then there is, you know, when you do things, then something happens. You try to operate that, you know, mixer in your friend's house, and you press a button and it starts mixing as you expected. Then you're like, whew, I'm glad that worked. So I guess I got this thing right. Or maybe it didn't, right? Maybe you tried to operate the microwave, you did something that you thought would work and it doesn't. Then you're like, you know, confused, despaired. And this has to do with the conceptual model that you're building, because as you encounter this unknown new appliance in your friend's house, you are super fast at building a model of how you think this thing might work, right? And all the things that we talked about, affordances, mappings, constraints, all play into this to help you build this model. And it can be right or it can be faulty, as we know, and that will lead to you feeling, you know, relieved and competent at using this thing, and satisfied or unsatisfied, and you know, unsure and maybe even nervous. All right. So when we say classic usability level, this is kind of the stuff that we've talked about before, right? So this is one where you like walk up to it and you would not expect things to be arranged in this way. As you can see, elevators are a source of endless fun if you think about usability. And now comes the third level. That is maybe the most difficult to get. It has a couple different angles. First of all, by the way, Alvina, you've got your hand up. Do you have a question? Then go ahead and speak up. Otherwise, maybe remove the little blue hand.
No, I forgot to raise it down.
Okay, fantastic, thanks. So reflective level, it means that you are now consciously thinking on events that have occurred. So you are reasoning, right? This is slow, deep thinking at the highest level, and it's related to the highest level of emotions that are often associated with the world around us and our social interactions with others, like, you know, guilt or pride or blame or praise, those kinds of things. They also get retained in memory and are therefore very important in your design. And it basically has to do with for example, when you look at this watch here, yes, it's a watch and it can tell the time, but the thing that is probably gonna, you know, that made the person buy this particular watch is that it's a Rolex, right? And it's a Rolex, wow, like nothing else really matters here. This person, you know, wanted to buy a Rolex. Maybe it looks great and feels great and it feels very, like, you know, high quality made, and that's the visceral level, right? Maybe also the, you know, it works exactly the way that you expect it to, so it's very reliable and handles itself in the right way. It's easy to set the time, etc. That's the behavioral level, but the overwhelming one, why people pay, you know, tens or hundred thousands of euros for these things, is none of those others, right? It's, in the end, it's the fact that it is a Rolex and that I have one. In this case, it's sort of like a social level of reflecting on the product. I hold, maybe I have this thing, I hold it dear to myself, I enjoy having it. A costly product may mean that I'm proud of being able to afford it, or that I want to reflect prestige. Or it may just be that I want to make sure that, you know, maybe I don't even care that, you know, you guys realize that I'm wearing a Rolex, because you're not the people I want to impress, right? Maybe it's like, I don't know, the tennis club that I play at. I don't play tennis, but let's assume hypothetically, maybe that's the people that I want to impress with my Rolex. All right, I don't play tennis, I don't have a Rolex, but, you know, please go with this. So when you have, like, for example, a painting and somebody buys the painting and it's an original, you know, Da Vinci or whatever, or original Picasso, and people are like, wow, he's an original Picasso, amazing. If then 3 years later they discover that it's actually a forgery, even though nothing about the painting has changed, you know, the perception of that painting in the eye of the collector will change greatly. And not just because he's losing money or he's wasted money, but also because, yeah, it's not the real thing anymore. Okay, so that's the reflective level. Now, how do these play into design? In the end, if you think about when you interact with a product, you've got these, you know, 3 levels, right? You first pick it up and you handle it, and I don't know, maybe, you know, let's take this watch here. It feels nice. I like the way that it's designed and how it's like polished, etc. The visceral interaction of it feels very sort of qualitative. Then there comes, you know, is it easy to use, right? The thing that we've talked about for most of the class so far. And then comes the reflective design. Oh, look, it's an Apple Watch. Wow, you know, I like wearing and proudly displaying my Apple Watch. So the point that I'm trying to make here is that if you do an excellent job at the visceral level and or the reflective level of design, you will actually be able to get users to like your product and enjoy your product, and because it speaks to them, and it it makes them happy on certain levels. And if you then have small usability issues on that behavioral level, they will maybe a little easier to be overlooked, right? Users will be a little more forgiving against those behavioral interactions. So basically those three levels interplay, right? On the other hand, if you do a really crappy design on the visceral level, if you've got something that just feels cheap and worthless, then it's going to be really hard to turn this into a product that people are going to love. Okay, I've got the spinner here at the bottom because I think it's a good example of that. You know that spinner, right? From setting the time on, for the longest time, this was the way to set the time on iOS. It's no longer the default, but I once had a guy here in the early days of the iPhone. He was from Motorola, and he gave a talk at our lab, and he said, wow, he was so confused about this spinner because he saw it, and he immediately realized that from a usability standpoint, from a behavioral design standpoint, it's not very good. It actually takes a fairly long time to set an exact time on this thing, right? If you've ever tried to do this, if you try to set a date and time, you have to spin these three wheels, and it's, it takes longer than just tapping onto like a date and a time, for example. But then he said he got his hands on the first iPhone. This was in 2007 sometime, and he spun these things, and he's like, wow, this is fun, like they spin and they make this clicking noise, and they've got just the right amount of delay so that they feel like a heavyweight wheel spinning, and it's just fun to spin these things. Now, so it's speaking to you in this case on a visceral level that is enjoyable to interact with. So even though it's not the perfect usability behavioral level design, it outweighed that by creating a design that on the visceral level was just fun to play with. So this is actually, go ahead, Matthias, you got a question?
Yes, regarding to this concrete example, isn't that just novelty? For instance, if I were to buy a coffee machine and whenever I turn it on and place a small jingle, well, at first it feels nice, sure, but when I make my 100th coffee, this jingle will get really annoying. Isn't it? I don't own an iPhone, so I cannot argue about this spinner, but I would imagine that it's similar.
Yeah. What you were mentioning is related. I don't think it's quite the same thing, because the spinner is still fun to play with when you're using it like the 100th time. It's just maybe at some point, most people who use it never notice that it actually takes longer than tapping this out because they're enjoying the time they're spending doing it, right? This is a thing that often notice, that people don't actually objectively realize how much effort they're putting into a task because they're distracted, or they're enjoying it, or they're not enjoying it, and that overshadows the actual measured time or precision of interaction. The machine that plays the jingle, yes, there's certainly a novelty effect too, and I bet that was also part of the effect that we had when the iPhone first came up with this thing in 2007. But the jingle playing coffee maker is not on the same level that it viscerally is enjoyable, but it is a novelty effect. And novelty effects, of course, they also work. They probably also work with that Swedish hairdryer. Look, it looks completely different. It's a new way of hairdryer. But those tend to get long in the tooth quite quickly, indeed. Alvina.
Yeah, so I'm a little bit confused about reflective design. Earlier you said that we need to think of what actions we have been performing, then we think slowly of them that they are done exactly the way we wanted them to be. This was reflective, right?
Yes. Well, when I said we are thinking consciously, what I mean by this is that when you try to judge the effects that reflective design has on you are triggered by you somehow applying conscious thought to this, higher level emotions. So not I'm enjoying handling this wheel right now, or that because it turns so well, or this knob or something, but more like, what does it mean to my peers that I am using this device and not this other device. So it is based on more conscious thought, more reasoning, but emotions still play a part. It's just emotions that are at a higher level, more things that are maybe more unique to us humans, whereas the other things are very, very fundamental, very, very low level emotions.
Okay. But this the statement create a prestigious brand, right? So basically this means the reflective and the visceral. For example, visceral is like when a product is attractive and we're like, wow, this is good. So if we are creating a prestigious brand, it's like if we see something from Rolex, we know that it's a big brand and watches,
So maybe
and suddenly we make it's attractive, right? So I'm a little bit confused here between reflective and visceral.
Yeah, sure. I mean, when you think about the difference here is, if you don't know the Rolex brand, and you see a Rolex watch on a shelf, it wouldn't mean anything to you, right? Whereas if you see a watch that is just designed with high quality materials and something that speaks to you that you'll enjoy handling, that will always work. You don't need to have prior sort of experience or know about a particular brand to make that call. So that's where I would draw the distinction.
Okay.
Fabian.
You just said that the Rolex wouldn't mean anything to you if we would see it on the shelf. I have a question for you. What about if you saw the price? And do you think people already have like this high opinion of stuff that's already expensive, even though if they don't know the brand?
Oh, yes, you're right. That could be another effect. So if you see something that is expensive, it's not that the price tag is speaking to you on a visceral level, right? But it is that you have a conscious process that says, oh, that's expensive. If I buy this, then I'm signaling to others that I can afford having this. So to a certain degree, I think that would already be on the reflective level. Okay. Victor, go ahead.
Yeah, I have a small question. Like, I cannot create an example without kind of prestige or credit of confidence, something like that. Could you provide another example with reflective design, but not with respect to, okay, I have Rolex, you know what Rolex is. Okay.
Well, I don't know. Maybe you're using, maybe you have a backpack that's made from, recycled bottles, right? And that's a good thing to have, no questions about it. But if you have that backpack and it's like a known thing that it is a recycled product, you're also signaling something about what you believe in and about your values. So you're basically communicating in a way to others through the product. It doesn't always have to be pride or any of these sort of possibly negatively connotated emotions or motivations, right? It is just, you are in a way you are communicating something about yourself through the device or through the system that you are using itself.
Okay.
I would recommend though, everybody take another read through that section of Norman. He's got a couple more examples and details on there, and I think it might become clearer if you once you read through that part. The last thing I wanted to cover, thanks for the questions, is how these things play into the 7 stages of action, because at different stages, actually different kinds of levels of design become most important. Essentially, when you start out with your goal and you plan things, this is more a level of where the reflective design plays most of a role. For example, when I use something and I have an overall emotional experience, like satisfaction about the thing, yes, this worked the way that I expected it to, or I'm unhappy, angry with it because it didn't do what it was supposed to be doing. That is more on a reflective level. So reflective is not just about how I appear to others, but it's also what I think about what happened when I consciously, well, reflect on it, right? When I consciously think about it after the fact. Next, when you look at the level of specify or interpret in the 7 stages, this is where the classic usability things come into play, right? I have a hope that the thing works the way that my conceptual model suggests to me, and then hopefully, it does it, and then I'm relieved that it works as expected. So expectations play a big role here. And on the actual level of performing the action or perceiving the immediate physical response, this is where you will be interacting with the object physically, and the performance may be shaped mostly by the visceral design of the device. Okay, so that's the 7 stages of action and these 3 levels of processing that go with them. Now, let's look at another fundamental distinction that is actually pretty important when you think about how things become more or less usable. And this is going to be another experiment that you guys need to do. So everybody, you need to take out a piece of paper and a pencil, or your favorite electronic drawing pad, and without looking at any of your devices or apps or something like that, just from memory, real quick, draw the layout of a keypad or keyboard from your telephone. It can be your smartphone, or maybe you actually still have a cordless phone with a keypad or something like that. And also draw the digit layout of a calculator. I'll give you a few seconds to do that. Okay, so you guys should all be done with this. Here's what we have in a typical phone layout. In this case, we just took the screenshots from the iPhone apps here, but that's what you will find at any touch type phone, basically, that has buttons. And if you look at a calculator, hardly anybody has calculators anymore these days. So we again took the corresponding app for that. It looks more like this. Now, I want to see a quick show of hands here. Who noticed? Who ended up with these 2 different layouts? If you had 2 different layouts, can you do a yes? Or a yes. And if you had something else than what you're seeing here, you can click a no. Okay. So we see quite a few people were able to recall these designs from memory, but many people also did not. And that's actually perfectly fine, right? I'm not trying to tell on you or to single you out. In fact, the surprising thing here is probably until today, when I consciously made you think about this, you had probably never noticed that these layouts are actually different, because every time you use one or the other, it's just there, right? So the point that we're trying to make here is that these layouts are actually not something that you need to have in your head all the time. I'll show you an interesting example here that I saw a couple years ago. This is a handheld PC that came out in like the mid 2000s, and it had mobile internet. Wow, could connect to the 3G network. And so what the guys did is they created this handheld, ultra small PC thing with a keypad, right? And you can see the keypad on the right. And it actually has, surprisingly, a phone layout. Now, I haven't spoken to the designers, so I can only guess that they maybe did that because they thought, well, this is going to get used on the road, and people are going to use the phone keypad to place phone calls. So they're used to this keypad from their, at that point, still button type phones, right? The iPhone hadn't even been invented yet. But if you use this as a PC to, like a computer to type, notes and stuff, then this is going to throw you off a lot because you don't expect the layout to be like that, right? So for a personal computer, kind of like for computer use, this is not the right layout. Of course, the solution to this has since been given to us by all screen touch smartphones, because they can just change the layout, as we just saw on the last page, based on the app that you launch. And it'll be interesting to see whether this distinction actually continues on in the years and decades to come, or whether at some point everything is just going to fall maybe into the calculator layout, because that may probably stay around longer than the buttons on phones. Who knows? The point here of this exercise was that there is much more knowledge that is in the world than what you actually have in your head. So this means that we actually don't have perfect knowledge of everything, but we can still act precisely. You do this every day, right? Every day you're using lots and lots and lots of cues from your environment to act and to do what you're setting out to do. And you cannot recall everything perfectly from in your head, but you can still act precisely. And that's possible because what you do is determined by the combination of these two. What you have in your head as knowledge and what's in the world as knowledge. And these two sort of connect to create enough information for you to act, hopefully, right? If everything goes well. This means, and this is kind of related to what we talked about in the initial lecture when we talked about what people can remember, that we don't actually need extremely high precision knowledge in our head if the details are given to us in the world, right? Well, all we need is enough knowledge, precise enough knowledge to be able to distinguish between the possible behaviors, to find the right one among those that are possible. This may be a little confusing, so I have another experiment for you. I want you to think about and write down or sketch, whatever you like, what is on the front and on the back of the German 1-cent coin.
There is a spoiler on the slide. The animation did not work.
Oh, how did that happen? Okay, I'm sorry, we messed up the slides here. It would have been a wonderful in-class exercise. So never mind. You can try this maybe yourself with the €2 coin or something. Okay, so what's on the back of the €2 coin? Think about that maybe. Because, I mean, the front will probably say 2, but is there something else on the front? Who knows, right? So, Jasper, go ahead.
So there are stars on the front to symbolize the European Union, and I think a sketch of the map of Europe as well. And I think on the back is our national emblem, the eagle. Okay.
So you think, and that's perfectly right? So unfortunately, I don't have a picture of the €2 coin here to tell you what it looked like exactly. But the point here is that you actually don't need to know these things precisely, right? Unless you're somebody who tries to detect, forgeries. When you basically reach into your wallet and you pick out, you want to find, like a €2 coin or a 1-cent coin, all you need to know is, how does it look different from the other coins that are in my wallet, right? And so you only need to have enough knowledge to distinguish the 1-cent coin from the others. You don't need anything more. That's what I mean by this combination of knowledge in the world and knowledge in the head. So basically, a lot of knowledge is not what you actually have in the head, although we think we do, but we actually don't. We often rely on cues from the world to act reliably. Okay, so a couple more reasons why this actually works. First of all, constraints are usually in effect. Oftentimes, you have constraints in place that limit the actions that are possible, right? So, for example, I have a Leatherman tool, and when you open up one tool and it is locked in place, you actually, you can't put it back in before you open another tool halfway. So there's a way that's protecting you from opening multiple things in dangerous ways. We've talked about physical constraints already, right? They're always at work. So let's say you are trying to repair your toaster, not that I would recommend it, but let's say you're bold enough to do that. There are going to be lots of things that you look at where you say, okay, this can move, this can be manipulated, this can be combined. there's going to be only so many options here that will help you to do this task, although don't have a perfect building plan of your toaster in your head. Cultural constraints, of course, are also in effect, right? So we don't need perfect knowledge, for example, on what to do in a particular situation, like, for example, when you enter a restaurant, because you know what to do, right? There's certain cultural conventions that will tell you what to do. And of course, this is a wonderful example where things can also fail, because I've been to many conferences in the US, and it's always wonderful to see how all the German visitors come into this restaurant and just walk up to a table and sit down, and then you've got the poor waiter or waitress there trying to gently explain to them that that's not how it works, that they're supposed to wait until they get seated at a table. So these cultural differences show us that these are things that don't work universally, but within a certain cultural area, they do work, right? On the other hand, we have lots of Americans that probably die of starvation at the entrance of German restaurants because they wait for somebody to come by and lead them to a table, and nobody ever shows up. So this is, again, an example of knowledge in the world, right? These cultural constraints are in effect. To give you an even more exotic example, back in the Middle Ages, there were poets that were traveling around the country. And they were making their living by reciting poems. And these poems had thousands of lines. Now, how on earth would they remember a poem with thousands of lines? Again, constraints are in effect, right? A poem actually has quite strong constraints. First of all, the kind of obvious one is that each line needs to rhyme with the one above. So once you know one line, you kind of know what the second one is going to end with. So that helps you, kind of, I would like to call it a linguistic constraint maybe. And secondly, the story that the poem tells is something that, of course, makes sense. It's not complete gibberish usually. And so that also helps the poet to step through the actual poem when he's reciting it. What that means is that constraints reduce the amount of knowledge that we need to learn, right? And we can actually use that to our advantage. We don't need to remember as much. We don't need to remember things as precisely or as deeply by just making use of these external constraints. And some people actually can use this by arranging their environment carefully to even cover missing abilities like dyslexia or mental disabilities. There are stories of people who had to handle, simple documents, and they were told, oh, this is a contract, and they would put it on one pile, and then they said, and this is an invoice, and they put it on another pile. And if anybody said, can you give me the contracts, they would just give them to them because they put them on the contract pile until months later somebody discovered that these people actually had trouble reading, right? They couldn't actually read whether there was a contract or an invoice, but by carefully arranging things so that they would always know what's where, they could actually work around that. Let me give you another example, and this is another little in-class exercise here. So think about typing, okay? You've now learned what knowledge in the head means and what knowledge in the world means. And I would like, here's a typical keyboard, and I would like you to think about when you take a beginner, a beginning typist who hasn't really done any typing yet and is just starting out, and somebody who's intermediate maybe, and then somebody who's ultimately a real expert in typing, can type really fast. What knowledge is in the world and what knowledge is in the head with each of these? Yeah, Lucy, go ahead.
So I think for a beginner, there's the alphabet in the head, so they know the alphabet, and then they have to look at the keyboard to see where they need to press for an A and for an X and everything. Mm-hmm. And then for someone who has worked with keyboards a little bit longer, then maybe they kind of know where certain, like the E and the A in the German language, for example, are. Mm-hmm. And then for someone who's really an expert, they can type without looking because they know where the keys are. They know how to move their hands. They don't mm-hmm. even know, like, and then of course this depends. I think it depends a bit on the keyboard. If someone who's an expert typer has a smaller keyboard, for example, than they're used to, then this could make it more complicated for them. And they might have to look at first, but then because the movement of the fingers is actually known, they might adjust to it faster than someone who's an immediate typer, intermediate typing person, because they might know where on the keyboard the keys are, but when there's more space between it, then they still have to look where the space is.
Yep, that's right. So what's happening here, you described it well, is that the beginner needs to look at the keys all the time. So that means the knowledge about which key is where is in the world. It's on the labels on the keys, right? And the intermediate person that, as you said, sort of starts learning frequently used keys, for example, will know the location of important keys by heart. So that knowledge is moving into the head. It's still in the world, but the user doesn't need it there, right? Because it's in the head. And then there is, partly still knowledge in the world at work, because there may be still some glancing down occasionally to making sure that I'm in the right row and stuff like this, or feeling keys or looking for less frequently used keys. And then finally, we have the expert, where all the knowledge has moved into the head and no eye contact to the keyboard is necessary anymore. Of course, this is a trade-off question, right? Because we might say, well, why isn't everybody just learning to touch type as quickly as possible? Well, it takes effort, right? And if you don't have to type that much in your job or in your life, then it may not be worth spending all that effort to learn how to type really fast. On the other hand, if your job consists of copy editing manuscripts or something, or if you're an author, or actually if you're a researcher, to be honest, you type so much that it's definitely worth learning this, because you will be you'll be using it so much. So for everybody, the trade-off between what level of typing skill makes sense, how much knowledge to move into the head, which is a conscious learning effort that takes work. We know this from what we talked about when we looked into the CMN model and learning. That will be different for each person. I remember when I started studying computer science, in my very first lecture, in my very first semester at the university in Karlsruhe, our professor gave us a simple sheet, an A4 sheet that had a paragraph of text on it. And he said, your assignment until next week is to type in that paragraph. And if it takes you longer than, I don't know, I think 30 seconds, I want you to take a typing class. Back then you could probably not take them online yet, but so he said programmers type so much that it is a horrible waste of efficiency and money if people in the computing business cannot type without looking. So anyway, take that as an advice. If you're still slow at typing, measure your typing speed, and if you think you could do better, then consider learning that. Anyway, so that's moving stuff into the head from the world, right? That's what's happening as you get more and more proficient with a particular technology. Here's another exercise.
There are still some raised hands. I'm not sure whether...
Right. Thanks, Ollie. Okay, so here's another example. I want you to try the following. This is maybe going to take a little longer, but I want you to try to write down exactly how you get from your home to the RWTH Hauptgebäude, the main university building. Or if you're studying in Bonn, you can use the main university building in Bonn. So take a piece of paper and write down instructions. It's also okay to draw a map, like a visual instructions where to turn left and right, and take a minute or two to try to do that. So what you probably noticed is, as you were trying to sketch this out, that if you look back at it, you can maybe open up Google Maps and verify what you did. You'll probably find that you actually left out maybe often entire parts of a route, or a street crossing. Or if you drew a map, then probably the crossings will be more prominent in your drawing because they are the important points, whereas a long part of a street where you just walk down or drive down won't be as big in your map either. So the point here is just to say none of us has a perfect street and building map in our head, right, of our home city. You may forget entire parts of your route in your description. Nevertheless, well, not right now because you're all studying from home, but usually you can make it, you know, 2 university buildings, 3 lectures safely, right? You find your way, you don't get lost, I hope. So how does that work? Well, because again, we have lots of knowledge in the world that we're relying on. For example, you know, street names, numbers of buildings, or important landmarks at a corner that all help us to, with external knowledge, to find our way, right? So this is another example of external knowledge that is basically helping us so that we can get by with knowledge that is less than perfect in our head. Now, when you think about what computer software does, is it provides us with knowledge of kind of 2 different types. In fact, there are in general 2 different types of knowledge. The first one is called declarative knowledge, and it's the easy kind of knowledge. It's the factual knowledge, right? It's the knowledge where you know the what kind of questions are answered, right? Facts like Bonn is southeast of Aachen, or simple rules, stop at red traffic lights, or you know, stuff like this. This is the knowledge that is actually easy to write down, easy to externalize, easy to put on signs, and easy to teach. Not necessarily easy to learn, right? It takes effort to learn it, but it can be structured and written down and taught and communicated in a fairly simple way. And guess what? Computers are pretty good at that, right? They can, an interface can relay this kind of information easily, right? The buttons in a software, or the menus that drop down, tell you exactly, you know, these are the options, these are the commands that you can execute in this software. The second kind of knowledge is procedural. So that's the knowledge that says how something is done, how to play, you know, the violin, for example. This is knowledge that is incredibly hard to write down because much of it has to do with the subconscious, with sensory images of certain sensations that we may need to have to do this. Things are playing together with multiple senses at the same time. And they are really hard to teach, right? They're really hard to write down and to teach. The best way to do that is by demonstration and hands-on training, right? You just imagine that you were going to set out to learn to play the violin, and you started by just reading a really, really long and good book about playing the violin. I don't think I'm going to come to your concert after you just read that book, right? I don't think you're going to be a very good violin player after that, because it's hard to turn this into, you know, written, externalized information. It's something that needs to be happening with you, with your body, with you in presence to actually learn that. In fact, some of the stuff that we're doing in this very class is of the same kind. You know, you can sit down and learn the CMN model, for example. You can learn, you know, the 7 stages of action. That's all declarative knowledge. That's easy to, you know, to write down, to teach, and you guys need to sit down and learn it. But, you know, we know how to do that. And much of university training is like that. But this class in particular will teach you some things like how to work with users to run a prototype and get feedback from them, or how to, you know, actually physically create a cardboard or hardware prototype with you know, some glue and cardboard pieces. And these are things that, yeah, I can write them down and you can read it, but you're really only going to learn it and gain the experience if you do it, right? So this class actually has examples of that. And I think this may be a class that has more of these kind of procedural knowledge types in there than many other classes that you're taking. Anyway, at least the declarative knowledge we can convey quite easily, right, in our interface design. That's not that hard. So we talked about the question of capacity of memory. And the CMN model gave us some numbers. We know that there are maybe 4 chunks of knowledge that can stick around in short-term memory. That's what current research is saying. We used to think it was more like 7, but it apparently isn't. But what are these chunks? I kind of glanced over this, and let's talk about this a little more here. So random unconnected facts are really hard to remember, right? Why? Because you can't actually literally learn things that are completely random. To give you a wonderful example, for the longest time, I had this example here that, Windows required you to press Control-Alt-Delete to log on. That this was the case in like Windows 2000 or something. And after, I don't know, 5 years of this class or so, somebody pointed out that I actually had it wrong, because my slide said something of like, I don't know, Shift-Alt-Delete or something, right? It was wrong. And it took 5 years for somebody to actually notice this. So this is really random facts, right? This is not something that you can easily remember. The way that you remember random facts is by associations, right? So, for example, why probably this Control-Alt-Delete to log on happened in around Windows 2000 was because this used to be the way to reset your PC, right? To reboot it. This was sort of the hardwired keyboard combination. And at some point, people thought, well, this is kind of what people have gotten used to restart the computer. So we're going to use that as a logon sequence. And if you had been using computers before, you'd say, okay, I remember that still. I'm going to use that same combination. But you're actually not learning it. You're learning it by association with something that you already know. A friend of mine once did a wonderful example in a class that I was teaching in Ulm, because he was a guy who was actually able to remember the first 1,000 digits of the number pi, which is kind of nuts, right? That's crazy. How do people do that? It turns out that he actually did not, of course, remember all the 1,000 digits individually as random chunks. That's impossible, even in long-term memory. What he did instead was he built himself lots of associations. So when he saw that the number pi at some point had, let's say, the sequence 747, he would say, oh, that's like a Boeing, right? And then if he knows that Boeing model, he would say, okay, I can remember that as one chunk. It's a Boeing instead of 3 digits. So that compresses it down to one chunk instead of 3 chunks to remember. And then maybe it was 747, 9, 747. So he could say, okay, there's 2 Boeings and a 9 in between. So that's actually a palindrome, right? It's like it reads back to front the same. So we have a palindrome with Boeings and the 9. So he's now compressed 7 digits into these 2 concepts, right? So this keeps just compressing more and more. And this building this literally a pyramid of these associations helped him to then unroll the whole number by going basically in like a depth first search down his associative tree to unpack the number. And it was fascinating to watch when he recounted it from memory, because he wasn't getting single digits wrong. Most of the time he got whole sequences wrong and put them somewhere else, because they had been somewhere up in the tree. He had made a mistake, and that led to him to, for example, swapping 2 entire parts of these 1,000 digits. The problem with these random unconnected facts, of course, is that you don't actually learn anything with any robustness. To give you an example, you've all written those instructions on how to, print a document for your parents, maybe for their computer, or for your grandparents. And if they are these like, cookbook recipes that say, press the blue button at the bottom right and press the red button at the top left, then if anything changes about the user interface, or if any error dialog pops up, they're lost, right? Without that, when the recipe fails, you're lost because you haven't built up a conceptual model of the thing. You just have these random unconnected facts. So connected facts are much, much easier for us to remember. That's how we do remember, right? We remember things by making associations. That's why remembering things that are connected to each other that make sense in how we like to say it actually is much easier. There's the wonderful example of this motorbike indicator. I think we talked about this last time, where if you went on a motorbike and you had to turn right, and you push the button forward, you're like, why am I pushing it forward? How am I ever going to remember that? It's a random, unconnected fact. But once you realize that that's what's actually happening to the handle, you make this association between the movement of your finger, your thumb, and the movement of your entire arm, that they are the same. And that association will then help you to easily remember that. So connected facts are way easier for us to remember because we do start then building a mental model of things. We're making associations. And if there is something that we cannot remember, then we just cheat, right? So let's do a little exercise here. Do a quick estimate on how many online accounts with passwords you have. You can just type the number into the chat. Yeah, so things go anywhere from maybe 30 to like or 20 to well over 100. So the second question, of how many of these can you, off the top of your head, remember the passwords to? You can give a percentage. like 3, okay. Yeah, definitely less than 100%, right? So very clearly. And then finally, for how many of these are you using the same password? I know we're not doing that, right? Yeah, 0. I can tell there's computer scientists in the room. Yeah, anything between 0 and 80% I'm seeing here. Very good. 90, nice. Yeah, that's how we cope, right? I mean, and online account passwords are just one part, right? There is credit card numbers, bank accounts with bank codes, number plates, phone numbers, addresses, birthdays, ages, and friends, clothing sizes, etc., etc. So this is all something that we are dealing with, right? We're somehow managing. Of course, people store things in password managers, right? For example, that's one way of doing it. You write things down because so as the password requirements become more complex, this makes the system become less secure. Why? Because we tend to move these things from the head into the world, right? Because we cannot actually remember random passwords that are like 18 letters long and 20 of those for different accounts. So we push things out into the world. And that's just to illustrate that this is actually something that is perfectly human and perfectly normal to do, and that already also indicates that security and usability really are things that are difficult to get under one hood. It's possible, but it's a difficult design challenge. So what's great about knowledge in the world? Let's look at this example again. Like we saw the letters on the keyboard, and the expert typists who had them all in their head. If the knowledge is in the world, there's nothing you need to remember, right? That's great, easy. So it's very easy to use at first sight, right? When you basically just walk up to a new keyboard, you can use it, right? You don't have any trouble. It's slow, but you can use it. You don't have a fundamental barrier there. But it's only there as long as you're seeing it, right? If you look away, or if it's too dark to see your keys, then all of a sudden you struggle using the keyboard, right? Try typing in the dark, for example. That will quickly tell you whether you're really a touch typist or not. Knowledge in the world is a good solution, but with things that are not super important to you, you probably will have trouble actually paying attention to the external cues. The solution, of course, to these things are reminders, right? So for example, if you say, I need to, take my Corona mask with me to whenever I go outside. You do something, right? You maybe put the mask next to your door or put it on your door handle. That's us basically, tricking our future dumb self into remembering this at the right moment, right? If you just write down, remember to take mask, and that note is nowhere to be seen, then it's not going to work. That's the big advantage of having your smartphone actually go off at the right time to remind you, rather than just having this item externalized. By the way, this is an interesting difference. We can actually, we don't always need to put the knowledge itself into the world. For example, if you say, oh, I need to really remember to, that I have a dentist appointment tomorrow, then, before you leave your apartment, you could actually just, tie a piece of string around your front door handle. And then the next morning when you leave your apartment, you see that piece of string and you're like, oh, right, wait, yeah, there was something. Yeah, right, I need to go to the dentist, right? You didn't actually put the information on there. You just put a trigger, a signal there that triggered the message itself then. Okay, so knowledge in the world, nothing to remember, available as soon as you see it. You don't need to learn. The initial usability is very high as soon as I walk up to it, but there are challenges, right? It's fairly slow because you need to interpret the knowledge in the world. You need to read the labels on the keyboard, for example. And the aesthetics with a lot of stuff to display become a little difficult, right? If you plaster everything with labels, at some point it just becomes, it looks ugly and it also becomes hard to use. If you compare that to knowledge in the head, it's less available, so it's harder to get to. You need to actually have it remembered. So it's not very suitable for beginners. It takes more time and effort to learn, but once you learned it, it's very efficient and it's essentially invisible. You don't need the labels if the knowledge is in the head. To give you an example, in court, the typists who need to type everything in for legal reasons that is being said in court often use recording keyboards where you press multiple keypads at the same time to enter whole phrases, not just individual letters. And they're incredibly fast at this. These recording keyboards are not labeled because how would you label them, right? One key can be used in dozens of different combinations, so there's no good way to label these. And they have it all in their head. They're really fast with this. But if you saw a recording keyboard, you wouldn't have any idea how to use it. So in this case, it makes sense not to have external labeling because the only way to use this device and to be proficient at it is to put it in your head. Of course, if you just do a cool design, I want to mention my PlayStation 4 again, that is completely hiding the buttons and the labels on these buttons to turn it on and to eject the CD just to look cool. That's minimalistic labeling for no good reason, right? Because that actually reduces usability significantly if you're not using this device every day. And there's a third way out though, right? You may be able to actually use natural mappings and all the things that we've talked about in affordances, signifiers, etc. Signifiers are labels, but if you use natural mappings, for example, you may get around having to label things, and you save people both the learning effort and the external labeling. That's knowledge in the world and knowledge net. So we now have a couple of different ways of looking at knowledge, right? We've got the understanding of procedural and declarative knowledge. We've got the understanding of knowledge in the world and in the head. And I want to come to another point here, which has to do with the question of how we make our way through complex information. So there are two ways that decision structures can be arranged. Thank you, Ali. So to reduce errors, a decision structure is, as an example, something where you're trying to let's take, I don't know, I do have an image for this now. You know, when you've got an ice cream parlor and you pick your ice cream, right? So an ice cream parlor menu, for example, is very shallow. You've got, you know, maybe 15 different kinds that you can take, but you don't have to go through many steps to make your decisions. You say, I want this one or this one, right? Or a menu that has 20 things on the menu and you pick one from the 20. So that's fairly broad, but shallow. On the other hand, a narrow decision structure can also help you. For example, like if you take cookbook instructions or how you start your car or stuff like this, takes only one decision at a time. That is very easy, usually a binary decision. We say this or that, and then you move on and you can forget about the other one and then the next one comes up. This is in fact how motorway exits are designed. When you want to look at usability, motorways are actually an interesting example because the way they are designed, the signage is designed, all makes sure that the cognitive load is as low as possible, right? It gives you an advance, okay, this exit is coming up, and then you may have noticed at some point, at the point where you are actually supposed to leave the motorway, you are not going to get the detailed information anymore what kind of exit this is, right? Because if you haven't made up your mind about whether this is the right exit or not, this is too late. You know, they don't want to confuse you and then get you to do a hazardous, like last minute exit turn because you suddenly discover, oh, this is the way to Berlin, you know? So that's why that information comes up earlier on. And then, you know, you either know that this is the exit you want to take or you don't, but that decision should already have been made. So it's also an example of a narrow decision structure that puts things one after the other. Things get difficult when these decision trees get both wide and deep, right? Chess, for example, is a great deep and wide decision tree, right? At each point, there are lots of options that you can do, that you can choose from, and there are many of these choices to be made during a game. That's because chess is designed to occupy the mind, right? To keep your mental facilities busy. But a user interface should not be designed like a chess game, right? A user interface should not be designed to fully occupy your mind and overload your brain. It's supposed to be effortless, right? So we want to make sure that we step through these things quickly. When we look at decision structures, there are two different kinds of thought that we also need to distinguish, subconscious and conscious thought. Now, decision structures are things that we step through with conscious thought, right? So, and that's because conscious thought is when you really are trying to think something through. You're consciously paying attention to something and processing it, reasoning it through. So that's when, you know, when decision structures are at work. On the other hand, subconscious thought is something different. It's effortless, it's associative, and it's often just pattern matching, right? For example, when you see a flash of light in the dark, your eye will, you know, go there and start looking there. That's not something you consciously do. It's just a reflex that happens. We're doing a lot of our processing for everyday tasks subconsciously. You know, it's highly parallel and effortless. It happens in an associative way, and we only can do one thing at a time in conscious thought. So that's why decision structures need to make this conscious reasoning easy for us. All right, we're now going to move into a section on feedback. We already talked about feedback a little when we looked at our Swedish hairdryer example, and Norman also talks about feedback as something that is part of what needs to be visible, right? So visibility is created by not just making the available actions clear, but also by telling me the results of my actions. So this is more about feedback. Feedback is basically how you communicate to your user what the current state is of the system, whether an action succeeded or failed, and what its results are. Good feedback is, of course, immediate. So it happens right when I do an action, just like in the real world, right? The moment you know, I hit a bell, that bell rings, obviously, right? If it's a physical bell. So when I press a button that is supposed to sound a bell, I want that sound to come out just as immediately, because that's how I expect it to work. Otherwise, it's unnerving. It doesn't feel right. It breaks things on a visceral level, but also on a cognitive level where I'm trying to make sense of the interface. Good feedback should be informative and clear so that I can understand it. Remember the 7 stages of action, right? When I go up this interpretation and evaluation step, then I need to have feedback that I can process well, that I can make sense of. Picking the right amount is hard for feedback. Not giving feedback, of course, is a bad idea usually, but giving too much feedback can be a nuisance as well. Too much feedback is like, your backseat driver that always tells you what to do at each crossing, at each turn. Imagine for a moment that you turned a text editor like Word into a mode where for every letter that you press, it doesn't just display the character on screen, but it actually pops up a little dialogue that says, you pressed the letter A, and then you click OK, and then you press another letter and think, now you press the letter S, and you press OK again. That would be a little much, right? So any feedback that is over the top, that is too much for the user, and that will also depend, of course, on the user, will be ignored or disabled if that's possible. And finally, not all feedback is created equal, right? There's feedback that needs to be placed into the user's face and that needs to be reacted to, like, your hard disk is on fire. And then there's other kind of feedback that can be related much more maybe silently or unobtrusively. So, couple examples. First of all, we're going to talk about sound as a feedback channel. And I want you to try the following here. Listen to everyday objects and their acoustic feedback that they give you, or if something is not available in your environment here right now at home, you can also think of things that you know. And let's hear some examples of stuff that makes noise and describe those. Where sound is a feedback. I'm going to just pick a few hands here. Sarah, go ahead.
At this very moment, I hear my clock ticking very loudly, and I think it's kind of a feedback to know that it's still working.
Okay, that's a good example. Clock ticking. I'm going to write that down because we're going to collect a few ones and talk about them. I think I saw Aparna there.
Yes, every time I plug on the charger and connect it to my MacBook, I hear a sound, and I don't care whether, I don't really care to check back. I just know that it's charging now.
Yeah, okay. Okay, good example. Sam, go ahead.
When making a coffee, the grinding of the coffee beans means that there's still enough beans in the machine left.
Okay, good. And Marius.
I have a little Bluetooth speaker, which when I turn it on, makes a little jingle noise that turns on. And if I connect, and if my smartphone connects to it via Bluetooth, then it also makes a little noise telling me that my phone connected successfully.
Great. Let's have two more. Julia Freitag.
Yeah, I have a dishwasher and a washing machine, and they both beep when they start, and they beep more often when they finish to let me know.
Okay, and maybe one more. Tejaswini.
Yeah, so I'm not sure, but this is about the fridge, like a refrigerator. It also has like a whirring sound sometimes, and depending on when it's doing its cooling action, the sound keeps changing. At least it does for my refrigerator.
Okay, good. Yeah, these were great examples. And you may have noticed we actually talked about two different types here. I mean, I've got more examples here, right? But the ones that you gave are just as good. And they fall into two kinds. We've had some things that are created naturally by the device without it being designed to create the sound, right? The clock ticking, or the grinding of the coffee beans, or the in fact, the cooling action of your fridge. Those are things that are basically, we hear them and they are a byproduct of the actual system activity or response. And then we've got these other kinds that are actually, that somebody designed to create that sound to relate something to us that wouldn't otherwise be as clear. For example, the charging ping on the MacBook, or the on jingle from the Bluetooth speaker, the dishwasher beeping at you, or the fridge warning sign when you leave the door open too long and it starts beeping at you. So you notice that there are two kinds of different design for sound feedback. Some of it is intentionally designed, and the other kind is just there, right? So let's look at sound as a communication channel here real quick. What do you think are advantages of sound over a visual communication channel? What's the advantage of having a sound output? In fact, I think who mentioned the charging ping from the MacBook? That was already pointing in the right direction here. Eugenia, go ahead.
I think sound is more difficult to ignore.
Yes, exactly. So that's both a blessing and a curse, right? So it's more difficult to ignore. So if a sound goes off, I can't just ignore it compared to a visual display. Related to that fact that it's difficult to ignore, anything else? Christina.
Yeah, it's like you if you hear something, you don't need to turn your head, and so you just hear it rather than if you have something visual, you have to turn your head to really see it. For example, with the MacBook plugin.
Yeah, exactly. So, and that again is a blessing and a curse, right? I don't have to look at it to notice the signal. But it also means I can't tune it out as easily as a visual signal, because the visual signal, as long as I'm not looking at it, it's not usually going to bother me. But if you have a coworker in your office and he has that wonderful function on that every time he sends an email, he gets that great swooshing sound for sending off that email. That's going to drive you nuts very quickly, right? So sound is directed, and sound is undirected, whereas a vision is a directed sense, and I can just look somewhere else and then not notice the things going on outside my field of view. But the field of hearing, unfortunately or fortunately, depending on the use case, is all around you 360. Okay, so those are a couple things that are different about it, right? So the omnidirectionality of it is definitely a blessing and a curse. When we do use sound, though, it really makes sense to try to convey meaning. I like the example of the dishwasher that is beeping once when you start it and then twice when it's done. So in a way, it's trying to tell you a little more than just giving you a signal, right? It's trying to also encode maybe a message. Of course, we need to learn that mapping, because the sound, unless it's clear text that says your dishwasher is ready, then you actually have to understand the signal and interpret it for yourself. There's going to be much more on sound in Designing Interactive Systems 2 next semester. For now, we're going to leave it at that I just wanted to give you a glimpse into how tricky and how unique the different modalities are. Our human senses are actually quite different, and you need to design for them in quite different ways. Now, just a few more words on visibility and feedback. A couple examples here. This is an espresso machine, a cappuccino machine I bought, and it looks very, very cool. It probably won a design award, but I should have taken that as a warning label because the on-off switch is completely hidden at the rear. Now, if you know this, the on-off switch is kind of back there somewhere. If you know this, then you can reach over and tap it. But it also means that it's kind of hard to see whether you actually turned it on or off right now. Sometimes you turn it on and then it turns itself off by default after a timeout, and then it gets confusing. And people who don't know this coffee maker always ask me, "Hey Jan, how do you turn on that coffee maker?" Right? So it's not very good for initial discoverability with this kind. Another example on visibility and feedback is VCRs. Now, you guys probably never had to use these, but video recorders, VCRs, had a long and sad history, right? First, they were just a video recorder where you could record stuff, and then this programming got added to them, right? So you could enter a time when they should start recording, which is great if you wanted to catch a particular show at a particular time. But all that programming was done on a tiny little screen that had basically no more than maybe 4 digits to display and a few LEDs or stuff to show you different programming modes. It was horrible to do. And only years later, somebody realized, hey, we can actually send an on-screen display to the TV connected. And so the VCR then showed an on-screen menu that was much more comfortable to use for programming shows into the VCR, and it showed you things in clear text and Thursday 8 p.m. or whatever. So that was much better. Unfortunately, shortly after that happened, VCRs kind of finally completely moved out of fashion, because at first people started recording digitally onto DVDRs and memory, and then now they're streaming. So VCRs have gone the way of the caveman. But it's a good example that, by discovering a larger display space like the VCR did with its connected TV, it was actually able to improve its usability quite a lot. Okay, so good display is great, improves visibility, often also usability. And this actually is becoming more feasible as technology progresses, right? In the 80s, 90s, the VCRs were technology limited by the display they could have. It was just expensive to put high resolution displays on them, and then they used the TV. Nowadays, it's a joke to put a touchscreen on a device, and so this has actually helped us to become for technology to become more useful. Another way to do that is augmented reality, right? That ability to enable a display on basically anything through, when you look through special goggles or maybe even through your smartphone with handheld augmented reality, is a great way to introduce more information. Here's an awesome example. I had a real car nerd in my class one year. He loved cars, right? And he was great. And he sent me this picture. He said, Jan, you're not going to believe what I found. This is in, what was it, Alpha? Is it an Alpha? Giulietta? Yeah, Alfa Romeo Giulietta. And do you notice anything peculiar about this car?
Yeah, I think it looks like there are 2 doors, but there's actually just one.
Uh-huh, right. Oh, that's wonderful. Because you got it wrong, that's amazing. It looks like there's 2 doors, but then it looks like there's actually just one because the other one doesn't have a handle, but it actually has 2 doors. Because this is the rear door handle. So I can only imagine what was going on in the heads of the design team there, probably thinking, oh, we're going to do something really cool and we're going to win a design award. We're going to get rid of that stupid old door handle that we've had for 100 years. Let's put the door handle into, like, next to the window and put it upside down rather than, you know, rather than make it vertical rather than horizontal. And it looks so cool and so clean. And I'm sure they had a great, I would have loved to be at the meeting where that was decided. It must have been amazing. Now, I can imagine a couple things. Okay, so first of all, let's assume you buy this car, right? So you're going to get a new car. You're all about your new car, and you're going to understand, oh, the handle is at the back. Maybe you even like it. You're like, oh, this is kind of fancy, right? Now you drive up, you know, to pick up a friend, right? And you stop where you're not really supposed to stop, and he's just supposed to hop in the car, like maybe here in front of the computer science building, Halifaxstraße, you know, you can't really stop your car there. It's going to be horrible. People are going to honk at you, but he's got to be quick, and he's got to get into the back seat because the front seat is already taken. You're like, yeah, get in. And he's like, man, you don't have a handle on your door. What's going on? And you're like, no, there is a handle. Look, it's right next to the window. And he's like, what? And then people start honking and the buses are queuing up behind your car. That's not a good experience, right? So then you start realizing that maybe this wasn't such a great idea, because first time usability of this car is totally bonkers, right? And now imagine, I mean, I hope nobody ever did this, but imagine somebody who runs a taxi service buys this car, right? They are going to have no end of pain with this car, right? So the point here is twofold, or maybe threefold. First of all, again, visibility and feedback, totally important, right? If you can't see where the handle is here, this is breaking everything about affordances, mappings, you know, and feedback and so on, and visibility. Secondly, there is a danger, you know, it's another example of something that probably won a design award, you know, should have gotten a usability warning sticker. And finally, though, even this design can work for a very particular use case where if somebody is continually using this car, they're going to get used to it, right? Because we're so flexible and adaptable to learn these things that we don't need to worry about it too much. We're going to figure it out. But anybody who encounters this at first, you know, relies on knowledge in the world to find the car opening handle is going to be completely flabbergasted trying to use this. All right.
Jan, there is a question.
Yeah, go ahead.
Yeah, one thing I wanted to ask you is, first of all, I think this design actually has some advantages because it might be more natural to actually grab it because of the direction of it, but it doesn't really matter. If someone discovers in a study for this to actually be the better solution, just disregarding the user experience, what users already know, and someone actually says, hey, we made a scientific study, this is technically better, just people are not used to it. What can you do? I mean, I would probably try to also move the front door handle to the top so that people don't think, hey, there's something missing. But what do you do in such a case? I mean,
Yeah.
how do you actually make great usability if you want to change something for the better, but if it's not known to the users how they should do it?
Yeah, dude, welcome to the world of design where it's always about compromises, right? Because what you're mentioning is actually a very real problem. Let me tell you an example of this. Does anybody here, you can just maybe give me a blue, like a yes or something. Does anybody know the Dvorak keyboard? We're among computer scientists. There's got to be enough nerds who know about keyboard layouts. Come on. Yeah, so a couple of people, very few here. Alexander, Alvina. So the Dvorak keyboard, for everybody to explain, is a different keyboard layout that lays out the keys on your keyboard differently from the QWERTY layout or Quartz layout that you're used to. And scientific studies have shown that the Dvorak layout is actually faster to type on than the QWERTY or Quartz layout. And there is a small, undying breed of hardcore enthusiasts that use the Dvorak layout because it's more effective. But you need to seriously rewire your brain, right? You need to actually learn typing on a different keyboard. And once you get to any other keyboard in the world that's not Dvorak, you're going to be faced with the problem that you unlearned how to type on that one, or you're going to make mistakes. So while everybody agrees that Dvorak is the better keyboard layout, there is simply no way to make the entire world change all the keyboards that are in existence from the predominant QWERTY layout to the Dvorak layout, right? It's just not going to happen. And so, yeah, it would be the better solution, but the hurdle to overcome here is too big. Not just, and this is especially because it's an interface that you are likely to encounter not just with your personal device, where you could say everybody can make up their own mind, but you're likely to also encounter it in public spaces. You imagine, the Deutsche Bahn went ahead and put a Dvorak layout on their ticket machines because they want to support the good cause, right? People would go nuts. And so it's the same thing with that radar handle. You may find that while there is a measurable improvement in usability moving to a new design, it either creates prohibitively expensive training cost, in which case sometimes the solution is to just let the old user generation continue using the old design, especially with software. That's usually easy because you can change the interface, and then maybe introduce an alternative interface that people can switch to, and that then the young generation then picks up and uses, right? So you can kind of phase out the old one and then introduce a new one. But the other thing is sometimes there is just, despite this apparent advantage in usability, the ecosystem around it will just not make it feasible to change it, especially not in an isolated case like this. So yeah, that's design, right? Sometimes you have to weigh these pros and cons. Almost always you have to weigh these pros and cons, and there's not usually that easy an answer as there is to a mathematics exercise. Okay. Finally,
again, there is another question.
Yeah, go ahead, Tejasvini.
Yeah, hi. So since you gave the example of the keyboard, I had a question from earlier when we were talking about knowledge in the head and knowledge in the world. So like the Mac keyboard is sort of different from the Windows or the Linux keyboards that you have. Like the control key or the command key, like the command key is not that present in the Windows keyboard. So then I know that I can distinguish that. But will that also be knowledge in the world? Because I can see that there is like this option key that's visible, and I know that it's different from the other keyboards. So will that be knowledge in the world or knowledge in the head?
Well, I think in the end, if you what's really hard is move back and forth between different keyboards, right? That's usually that's pretty tricky, and it usually means that you need to, at some point, you can develop sort of a mode switch where you say like, oh, I'm typing letters, I'm doing this on my PC keyboard, but I'm doing this coding exercise in Xcode, and I'm doing that on my Mac, and that's slightly different. Usually these things will continue to lead to small mistakes that people make because the keyboards are too similar, so they tend to occupy sort of the same space in your brain, if you like, and you're going to make mistakes, mode mistakes, basically mode errors. We're going to get to those in a minute, where you think you are on a PC keyboard when you're really on a Mac keyboard. But just to blow your minds, we actually use US keyboards at all our computers at the lab, which seems to totally contradict what I just said. But again, it's a design choice. We code so much, we have to write so much code and code related stuff. Even writing documents in LaTeX, for example, is essentially like writing code. And we do that all the time for all our papers and theses and what's not, so that we decided to get US keyboards for all our machines. You can imagine the occasional heavie who comes into our lab who's like, what's going on here? It's, US keyboard. And if you program a lot, you will love the US keyboard because all the keys that you need frequently are easy to reach on US keyboards and not easy to reach on German keyboards. But if you have to go back and forth between them, again, it's a constant struggle. So feed forward is the same thing for execution as feedback is for the evaluation part on your 7 stages. It's information that helps you to know what you can do before you even do it. Feed forward is sort of an umbrella term in Norman's world for signifiers, constraints, and mappings. So it basically has to do with the visibility of available actions and state. It's largely visual, although I will say personally, I found the concept of feed forward really useful to think about in other modalities. For example, the haptic modality. When you think about typing on a real keyboard, a physical keyboard, or typing on a touchscreen, like on an iPad or on your smartphone, the physical keyboard has the advantage that before you press a key, your fingers can actually feel the keys and know where to place, you know where to place the fingers by feeling out the keys and arranging your fingers just so. That is something that the screen cannot give you because it's just a flat surface, right? So you need to basically go by memory or by looking when you want to type. That's why typing eyes free on a touch screen is really, really hard, because you're not allowed to drift at all. Whereas typing on a physical keyboard eyes free is totally possible because your fingers keep getting that information on where the keys are exactly, so they don't drift over time. So feed forward is a super important thing, and it's especially something that will help you when you think about it in other senses than the visual sense. Now, we have a few more things to say about human errors. Human errors are totally common. People make mistakes, make errors all the time, right? It's totally typical and nothing to worry about, right? In fact, it is an untypical thing that people often actually blame themselves when they make errors with using technology, although usually we are very ready to blame the other person when something goes wrong, right? And they're often caused by taught helplessness. Now, people maybe thinking, oh, I'm not good in math, and then I'm not good with computers, and I can't use this, I'm too stupid for this. I'm sure you've all heard this from someone in the past, that they say this. And this may actually lead to learned helplessness, where people are afraid to speak up, that they say, well, I can't use this thing, I don't know how this works, this is not usable for me, which is can be really depressing if you basically feel that technology is overwhelming you and you don't feel in control. But errors are totally normal, right? People make mistakes all the time, and software designers like you guys often make the mistake to think, oh, stupid user, it's another dumb user who makes a mistake here. That's not the case. The key message that I want to get across in this class is that if a user makes a mistake with the system, we should start blaming the designer and figure out whether the designer could have done a better job. That's the first point to look, not the user. So about these errors, we may think, oh, that's just dumb people who have these misconceptions, right? But that's not true. As an example, with thermostats, a lot of people will, if they want their room to heat up quickly to a particular temperature, will crank their thermostat up all the way. That doesn't change the curve at which you get to that temperature, really, because it will only turn off when it has reached that temperature. But people think that it somehow is faster because they think of it as a simple valve that opens the heating more or less, even though the thermostat is basically just turning things on or off in a pretty much binary way. And these mistakes are creating friction in use, and or these errors, and we have to distinguish two kinds of errors that are happening. The first one are mistakes. Mistakes are things that happen as a result of conscious thinking, conscious decisions. There are often major things that go wrong, and they happen because you had a wrong goal or a wrong plan, or you leaped to wrong conclusions, or you had assumed a false causality. This example that maybe the first time the internet router went off was just when your grandparents turned on the light in the kitchen, and so they're like, oh no, the light turns off the internet, right? These are hard to detect because users are convinced that they're doing the right thing, right? They're making a conscious mistake. For computers, software especially, they are incredibly hard to detect. It's hard to put up an error message or to realize an error situation when the user is convinced they're doing the right thing because they have a plan. So mistakes are tricky to capture. And here are a couple examples of them. You'll find more details on this in Norman's book. There are memory lapse mistakes, which means basically you have a memory fail during your goal setting or planning or evaluation. So for example, a mechanical failure because you know, the guy working on troubleshooting a device was distracted while he was troubleshooting. They can also be knowledge-based, where you look at a situation and you evaluate it consciously and you come to the wrong conclusion because you didn't have all the knowledge that you needed. For example, let's say, you know, you report the weight of an item in pounds instead of kilograms because you weren't sure which unit was being used. The third example of mistakes are rule-based. So you look at a situation, you evaluate it, and you choose the wrong course of action. So for example, you know, you might be, you know, the bumper at a nightclub, and people are heading for the emergency exit, and you think, oh, these people just want to, you know, avoid paying their bill that they've racked up in the nightclub, but they're actually fleeing because there is an emergency. So after mistakes, what you can usually assume is that people will say, yeah, I did what I intended to do, right? It's not something where that they immediately say, oh yeah, I had a slip. The slips are the second kind of mistake of errors that happen. So errors fall into mistakes and slips. Mistakes, very broadly speaking, are conscious wrong decisions for some kind of reason, and slips are most of the mistakes we make every day. Most of the things that there are small things going wrong. So slips are you have a goal, but the execution was somehow messed up. They are usually easy to discover in software because they are clearly behavior that wasn't intended. They occur mostly in skilled behavior. So when people don't pay attention anymore. So the person who is learning things and doing every step consciously usually doesn't make slips. It's the person who has started to learn something about a system and starts, you know, throwing off the training wheels, who starts making these mistakes. They're often caused by lack of attention because I'm busy, I'm tired, I'm stressed, I'm bored, or I have more important things to do. It's important to realize that consciously we can really only do one thing at once. Jeff Raskin, who's the co-inventor of the Macintosh, wrote a wonderful book called The Humane Interface, in which he gave this example. He said, you can walk down the street and you can eat peanuts and you can solve a math problem in your head. You can do all these three things at once. But the only thing that is occupying your conscious thought there is solving the math problem. The rest is happening subconsciously. Walking, eating is not something that you need to consciously expend thought on. So I would say slips are more relevant in interface design than mistakes are. And slips fall also into several classes. There is, first of all, the action-based slip, which basically means you just performed the wrong action. So to give you an example, you pour a cup of coffee and milk, and then instead of placing the milk back into the fridge, you place the cup back into the fridge, right? So you basically chose the wrong action. And this could be because you made a capture slip or a description similarity slip or a mode error. We're going to talk about these later. The second class are memory lapse slips. They are memory fails, where your intended action is not the one that you end up doing, or you don't evaluate the results. For example, you leave the house and you lapse, you have a lapse in memory and you forget to lock the door when you leave the house. So let's look at these action-based slips here in a little more detail first, where you perform the wrong action. I said there's several subtypes here. Capture slips are ones where you've got two action sequences with a similar starting point or initial sequence, but later on the sequence differs. And in this case, the sequence that is well practiced will capture and overtake, so to say, the unfamiliar one. Let me give you an example. Maybe you've experienced this. If you drive, to work every day of the week to the same place, and then on Sunday you get in your car and you really want to go somewhere else, but you kind of, you space out, and all of a sudden you find yourself taking that turn that you take every day of the week, of your working week, because it's the turn that you're used to, right? That's where getting in the car and starting to drive was the same sequence on the weekend and during the week. And so because you do that weekly routine every day, it captures the unfamiliar one where you wanted to go for a different location. Or very common, you need a pen to write something down. Somebody gives you a pen, you write your signature, whatever, and then you pocket the pen. That's not because you're an evil thief, because it is because usually when you take a pen to write something, you put it back in your pocket, right? And it's only in this case when your pen was somebody else's, that starting sequence of writing something down basically captured the end of the sequence, and you pocketed the pen. So that's capture slips, fairly clear, I think. Second one, description similarity. This is when the intention of the action was not described in enough detail. So you're starting with something, and the intention isn't described in enough detail, so it fits two different action sequences. This often occurs if similar objects are physically close to each other. For example, switches. But also, you basically come home from sports, you take off your shirt, and you're like, you're tired, and you go into the bathroom and you throw the shirt into the toilet, instead of into the laundry basket. Because, hey, all your brain was able to do at this point was to say, throw shirt into round object that's open at the top, right? And the toilet fitted that bill close enough, so you toss it in there. Or, and I'm sure you guys have all done that one before, you have breakfast, and then you're like, still kind of tired because the coffee hasn't kicked in yet, and you start closing all your lids. And after, you're closing that orange marmalade jar, and after about 20 seconds, you realize this is not working because I have, the Nutella lid in my hand and I'm trying to put it onto the jam jar. That's not going to work, right? So again, description similarity, the two lids and the two containers were so similar that you just picked the wrong ones. Or pouring orange juice into your coffee pot in the morning because you're just too tired, right? So that could happen in description similarity slips. Another example of the action-based slips, this was the third one, and probably the most frequent one maybe that we see in computing are mode errors. Mode errors are something we can actually identify quite well in computer software. Mode errors happen because a device is in a different mode than what we thought it was. And because we then do an action thinking the device is in mode 1, but something else happens because the device was actually in mode 2. Now, this is a question out there to the Linux geeks in the room. I want to see if anybody knows what this sequence of characters is. Why would that sequence of characters ever end up inside a text that you've been typing? Anybody seen this before? Yeah, Aparna, go ahead.
Yeah, it's for saving and quitting the VI editor.
Right. So this is the sequence, the command sequence that you type, into save and quit the VI editor, right? And the VI editor is great because I think not enough people have probably actually seen the VI editor here. So I'm going to do a quick live demo. Hold on. Just going to launch a terminal here. Okay. You guys should now be seeing a terminal window, right? Is that, yeah? Okay, good, thank you. So I'm going to launch VI here. This is the wonderful VI editor. And the way VI works, you might think, oh, I have a text file now, I can just type. No, you cannot start typing. You actually need to press the I key. I'm going to press the I key now to enter the insert mode. See, it says down there at the bottom now, insert mode. And now I can type something in. And if I now want to do anything else, like for example, save the file, I need to hit the escape key to get out of insert mode. And now that has gone away. And now I can move somewhere else and do something else. And if I now press, for example, if I want to type hello there and I start typing T, it interprets that as a command and nothing happens. T, see, I can move, some of the keys do other things in this mode, but it's not typing. So I need to press the I key again to get back into insert mode and type keys. And when you press escape, you're in this command mode. And then when you press colon in this mode, you enter yet another mode, which takes you down into this little command line at the bottom there. And there you can say WQ to save the file. And then it doesn't have a file name, so it's going to ask you for a file name and so on. So this goes on forever. But the key point here is, I'm going to go back to my slides. Mode errors are examples whenever, something like the VI editor has many different modes in which pressing the same key does different things. And mode errors happen whenever devices have to resort to modes because they have more functions that they need to deal with than they have controls. That's the biggest problem, and probably the most prominent problem in many software user interfaces. To give you another example, there's a window manager in some flavors of Linux that will let you kill an app. And to kill an app, you basically select the kill app function. It's a menu somewhere in this window manager, and then your cursor turns into this little skull, skull and bones, and then any window you click on will be killed immediately, right? Kills the process and immediately closes the app without saving anything. Sounds okay, but the problem is if you select that and then you get distracted because your phone rings or you have to do something else, somebody is at the door, you need to get a parcel, you come back to your computer and just to continue working, you click on, your file where you were writing your thesis or something, you click on that window and boom, the window closes because you are still in that mode of clicking anywhere now kills the window. That's a terrible mistake, right? It's a slip and it's a mode error that you make, and it's because the system was in a different mode than what you thought. That's why it's usually a good idea to avoid these modes in software if you can, and instead of that, resort to people selecting things first and then selecting the action to do on them. So I select a window and then I say kill this window, because then I'm not going to make a mode error because I select the command the moment it gets to be effective and I know what I'm doing. Here's another example. Does anybody see the recipe for frustration in this screen here? Actually, it took only a little while to figure that one out. It's not that obvious. Why is this person not going to be able to log on or to install? Sorry, Fabian.
Yeah, it's because he has caps lock activated.
Exactly.
You see it on the little arrow, which is already an improvement to not seeing an arrow. Which was
absolutely.
like 10 years ago,
totally.
you never had these.
Exactly. There used to be, back in the days, right? There used to be the time where you didn't get this indicator in your right where you're typing. The only way to tell was that there was this tiny little green light on somewhere on your keyboard. And if you didn't see that, then you'll be like, what's going on? I know this is my password. So now it's indicating to you, I'm currently in caps lock mode, right? Caps lock is a mode because the moment I press that key, the normal keys are doing something else than they usually do. Interestingly, the shift key is not the same kind of mode because the shift key needs to be held down while it is active. You're never going to make the mistake of, oh, I typed a capital letter because accidentally I had held down the shift key, right? That's very unlikely. You don't forget that you're pressing the shift key, but you can easily forget that at some point you pressed the caps lock key and it switched into this different mode. There's a name for these special modes that only are active as long as you hold something down, and they're called, again, a wonderful term by Jeff Raskin, quasi modes. On the one hand, because they are kind of like modes, but not quite, but also it sounds like Quasimodo, and it's kind of a cool word. All right, moving on. Memory left.
Jan, there is a question.
Oh yeah, go ahead.
Well, there was a question.
There was? Maybe there still is?
It was a minor remark.
Go ahead.
This special passwords window, I believe, is somewhat outdated because typically you expect this eye icon, which lets you see your passwords to avoid those problems.
Yeah, so that's another. So it's an interesting point that you make. So the eye icon that then lets you reveal your password is another option to address this usability issue, but it takes a slightly different path, right? Because the caps lock is an indicator that just brings an existing system state closer to my attention, and I don't have to do anything. It's just there, and it will remind me to know, oh, okay, I'm in caps lock, and then probably I'm going to turn caps lock off. Whereas the I might type in a password, and maybe I've got 3 people looking over my shoulder, and maybe I don't want to reveal my password to everybody. So when I press the I icon, first of all, I need to do an explicit interaction with it and then see what the problem is, if I get that far. And then also everybody is going to see my password. So you're right, this is another way to alleviate some of the problems people have with passwords, for sure. More universal as well, because I might have actually some other problem. Maybe I'm switched to a German keyboard layout and I'm using a US keyboard and I'm mixing things up because of that. So it's more universal in that way, but it also is more revealing from the point of the secret of the password. Okay, thank you, good point. So memory lapse slips are the next kind. They are very common cause of errors. They're caused by interruption through other people or devices, like I was just mentioning when suddenly the phone rings. So I bet you guys have been there, right? You walk into your bedroom from your kitchen and then you're like, wait, what was I going to do here? I'm sure that's happened to you guys as well. And is it amazing that you can fix it by actually then like going back to the original room, and that will kind of reset your brain and someone like, oh yeah, right, of course, I wanted to pick up my pajama. So yeah, the human brain is amazing. Sometimes these memory lapses also happen because the main part of the goal is accomplished, right? You go to an ATM, the Geldautomat, right? And you put in your card, you get your money. And back in the day, oftentimes people would walk off with the money because they forgot the card, because the goal of the whole thing was to get money, right? So they would forget the card in the machine. So nowadays, most machines will actually require you to remove the card from the slit physically before they actually disperse the money, right? So that's a built-in interlock, actually, that's a sequencing thing to counter this memory lapse slip that happens very frequently. Or, I don't know, maybe you've been there, if you photocopied something and you left the original in the copier because you happily walked off with the photocopy, totally normal, because the goal of the whole thing was to get the copy, right? So that's another example of a memory lapse slip where you're not completing the action. So we can minimize these things by reducing the number of required steps so that people don't forget one, providing reminders of the steps, and applying forcing functions like the ATM does, for example, not giving you your money until you took the card out of the slot. Okay, so those are a couple of different interesting slips. Maybe we can have a very quick exercise here. I'd like you to think of a few examples of slips that happened to yourself, okay? Now is the time where everybody needs to be, honest about themselves. Tell us the stupidest thing that happened to you that was because of some kind of slip. And if you can think of a few, then also maybe think about what kind you think they were. Was it capture, like the driving to work thing, or was it the description similarity? Was it the mode error, or was it a memory lapse like the money card thing? All right, Lucy, go ahead.
So it's not really the dumbest thing that I've ever done, because I've done a lot of dumb things, but something that's happened very frequently in the last days is that I go into the kitchen and I make myself a tea. So I put on the thing that makes the water hot, and I put the tea bag in my cup in my cup, and then I put the water in, and then I heat the water, and then I forget to put the water into the cup, and then I do it again because I forgot that it was hot and it's not hot anymore, and I do that three times before I actually put the water into the cup and can drink the tea. And then I also sometimes forget the tea in the kitchen because, and I think that's really a memory lapse that happens all the time because I think about making the tea. So I do all the steps to make the tea, and then I forget to actually put them together.
To complete the sequence, so to say, because there's significant time also between some of the steps. And then probably something else distracts or gets your attention, and then it's easy to go and have a memory lapse slip and forget the rest of it. So see, you're not to blame. It's perfectly normal. It's all good. Here, let's see, Jona.
Some time ago, before the Corona started, I bought a new bike and I drove to a lecture with the bike. And on my way home, I just didn't think of I came with my bike, so I just go into a bus and drove home. And when I arrived at home, I just recognized, oh, damn it, my bike is still there.
Very good. That's a really good one. Thank you. What kind of mistake do you think that, or I shouldn't say mistake, what kind of slip do you think that was?
I think it's capture.
Yep, exactly. That's how I would classify that as well. You had an established routine, come out of the lecture, go to the bus station, hop on the bus, and that routine was so ingrained that it totally took over, even though if somebody had asked you afterwards, what did you intend to do? You would have said, yeah, I wanted to do something else. Good, great one, thank you. Let's see here, Tassin.
Yeah, so this is something very embarrassing that happened to me. I actually arrived in Bonn like 2 days back. And so I was getting from Tannenbusch to the Hauptbahnhof. And then I had to go from Hauptbahnhof to the university station. And I actually took the train, like I did not change the platforms. And I took the train back to Tannenbusch again. So I reached the place where I started from. I am not sure which error that is classified as, but yeah.
That's a good one. I think as cause of the error, we can probably also say massive jet lag slip certainly plays a part there. But yeah, I would think maybe it's a memory lapse where the sequence that you had planned wasn't being executed because something distracted you. Or, you could also argue for description similarity here, saying like, okay, I'm on a platform, there's a train leaving, that's close enough to what I'm trying to do in my foggy mind state of jet lag, so I'm just going to get on that train. So I think those would be valid explanations. Wonderful. Let's see here, Fabian Reinhardt.
Yeah, so I actually have a memory lapse slip, and it's quite the opposite of one you mentioned. So I put in my my credit card and went to put in my PIN, but I really have to think a lot about my PIN because I have like 3 different cards depending on where I take money. So that's like a little bit difficult. And I do everything. I take out the card and then I just leave without taking the money. And I just forgot the money there. And usually that's not a problem because it takes like, I think 30 seconds and then the money is just pulled back in if it's not taken out. But I was actually really annoyed because somebody took the money from there and went away with it. So I noticed it when I wanted to pay something, and then I checked my bank account and the money was actually taken from it. So it was really annoying.
Yeah, that's annoying. So what do you think? Which way would that go? Which does that fit any of the types of slips?
I think it's a memory lapse, but I actually did not really fulfill the goal, so it's kind of debatable.
Yeah, I agree. Hard to say what's going on there. Okay, we'll take one more, and then we need to move on, I think. Rachel, go ahead.
Yeah, this one was just yesterday. I wanted to help Lucy, she's my roommate, to cook, and she had the package from the things that she wanted to cook on the table, and I thought that she was already cooking, and I wanted to throw away the package just to help her. And then I took it, and everything went on the ground because it was still in there. And I just didn't I thought I can just throw it in the bin because that's what I usually do when I'm trying to clean up. And I just didn't realize that there was still everything in there, and it was quite a mess. So I think that was also a memory lapse, or maybe a description similarity, because that's like something you usually do.
Yeah,
so that was what you were trying to do. I asked myself that the whole evening.
Well, I love this. This is turning into Big Brother here. I love it. Yeah, no, this is probably sort of a description similarity because that bag probably looked pretty similar to the ones that you usually toss away when they're empty. So great, thanks everybody for sharing. We're going to move on and now try to think about, okay, when all these errors are happening, how can we detect these? We already said that detecting slips, so the things that happen because people weren't paying the right amount of attention, they were distracted or something, are easier to catch than mistakes. But you still need visible feedback, right? And as an example of that, there's this wonderful story where somebody is driving in the car and then he yells over to the passenger in the car with him, can you adjust the window, please? And the passenger is like, how do you mean adjust the window? Open it, close it? No, just no, adjust the window. And usually what people do when the other person isn't doing the right thing is they just say the same thing but louder, right? Hoping that will help. And trying to debug on that level. And I'm like, I don't know what you want me to do. And then finally they realize, no, I want you to adjust the window. Oh, you mean adjust the mirror maybe? Oh, yes, of course, that's what I was trying to say. So because if the person who is being yelled at isn't giving feedback by, for example, repeating back what was being said, then it's really hard to catch that, right? Because you're not looking for a mistake in that sentence in your own utterance. So similarly with software, right? When you provide visible feedback, it's going to be easier for people to catch slips. Another example is how we go through these things, how we detect errors, is usually happening in sort of a bottom-up fashion. And of course, action-based slips are easier to detect than memory lapses are because the feedback is actually tangible, right? It's easier to catch that way. Mistakes are really hard to detect because nothing is actually signaling us a wrong goal at all, right? There's nothing in that sense. Now the problem, of course, is how do we find the right level at which we should be correcting? And there is some indication that we may be doing our own error processing in a bottom-up fashion. The example I have here is, you know, I think the book mentions this, you know, somebody walking up to their car, trying to unlock the car, it doesn't work. So the first thing you try is you turn around the key, right? You try it the other way around, doesn't work. Okay. Then you look at your key, you know, your keychain, you're like, am I trying this with the wrong key? You try other keys until you finally take another look into that car in the parking lot and you realize, oh, wait, that's just another person's car that looks very similar to mine. Mine is parked over there, right? So in going through this, we are kind of debugging things from the smallest to larger issues, right? Is it just the key held wrong or the wrong key, or is it completely the wrong car that I'm at here? So there seems to be this bottom-up stepping through that we're doing. Notice that confirmations are actually pretty unlikely to catch these kinds of errors. You've all seen these confirmation messages. Programmers love to put them in, but although they don't really work well, that say, are you sure, you know? And are you sure is, you know, it's a very minor bump to do it, but if it's in a dialog to delete a file, then you will just turn, you know, you will just get into the habit of delete, you know, issue the delete command, then click OK on the "Are you sure" button, and then move on, right? We've all gotten used to these things. So if this dialog comes up every time and it's just a mechanical thing to do, very quickly it will become part of the routine. So I don't stop to think when that dialog pops up anymore. What could we do? Well, you could say every time somebody wants to delete a file, you don't just ask them, are you sure? But you say, are you sure you want to delete the file blah.txt? You know, whatever it is. That's a little better because maybe I tried to delete the wrong file, and seeing the file name again in this dialog will wake me up that this is the wrong one. Or maybe showing a little preview of what's in the file so that, you know, I get a hint at maybe that's not what I wanted to delete. But even those are things that people will quickly get used to. If all they need to do is press OK, they will just press OK as part of the sequence that they learn, right? It will just become one command. What you could do is you could say, I really want this person to stop and pay attention and think at this point. So you could say, if you want to delete this file, please enter the file name now in reverse order. I am sure that will stop you and make you think, because now you need to type in the file name in reverse order, right? So no more automatic going through the moves and deleting it accidentally. But is it a good solution from a usability point of view? I don't think so, for two reasons. First of all, oh, Fabian, you know, you have a suggestion. Why do you think that's not the right solution? Fabian Friedrichs.
Well, you would probably just find a stupid workaround around that. For example, just use palindromes or something.
Okay, I wasn't even going to go that way, but you're right. That would be one way to work around it. But when you stop, first of all, it will stop you thinking, but you will now spend your effort on reversing that file name. So that's a different cognitive process that doesn't really lead you to thinking through, is this the right file? Right? Secondly, it's annoying as hell. So deleting a file now becomes an arduous task with an extra tagged on little thing to do, you know, that is just gonna slow you down. So not really helping, I think, in the right way, and creating a lot of friction in the interaction for a small price, for a small gain. So the better way to do this is, of course, to have actions that are reversible instead. Like the trash can, right? For example, I can always delete files on my computer, put them in a trash can, and if I decide then, you know, a minute later or the next day, oh, I shouldn't have deleted that, then I can pull it back out. And the only time I'm really forced to make a hard decision is if I should run out of space on my hard drive and I need to empty the trash to be sure. So that's good, right? Because that's an easy way to let the user undo what they did to recover from a mistake rather than forcing these confirmation dialogues upon them. Okay. So there is, if you want to look at it in a different way, memory lapse slips and memory lapse mistakes, this often it looks very similar. In the first case, you have a single component of a plan that's being skipped, whereas in the second, you forget about the entire plan. Right? So that sort of is the distinction there, by the way. Okay, now Norman calls it the paradox of automation, and this is becoming more and more important because we're seeing increasingly, machine learning algorithms and stuff trying to automate things. And automation is great, right? If it works well, then tasks are done at least as well or even better than if people did them. But the paradox is that automation can take over all the dull and simple tasks, but it cannot take over the really complex ones. Those still require a human. And when automation doesn't work, the results are actually unpredictable and can actually be dangerous, right? Think about self-driven cars, for example. This is a huge challenge currently for the car industry, who are trying to get cars to be more and more autonomous. But if you, for example, say, I'm going to make the simple driving down a highway with no other car in sight, make that autonomous, and you can let go of the steering wheel and do whatever. But the moment a situation comes up that the car finds too complex, suddenly the driver has to be back in control again. At that time, maybe he is, solving a Sudoku or something. So it's really tricky to do automation well because of this, switching back to human engagement, especially in these safety critical things like cars. And the second challenge of automation is many, many times the automated version is way too stupid for reality. A lot of these, smart systems try to be smart, but then they fail because they don't reflect the complexities of reality, and the solution is actually not done as well as a person would do it themselves. And then it becomes just annoying or even dangerous. So automation is not always a way out of mistakes that people make. So we need to design for errors. Right? We need to design for the fact that people make these errors. So assume that all possible errors will be made. And I want to add one to them. I want to actually also ask you to assume that all impossible errors will be made as well. These stories that from support hotlines that say, oh, hello there, is this a support hotline? Yeah, I'm trying to install your software, but it's not working. Disk 1 installed fine, but disk 2 somehow, I can't get disk 2 into the disk drive. And then after many, many back and forth, they realized that the person actually didn't take out disk 1 before they inserted disk 2 into the drive. So it's really amazing how creative people are in making mistakes with the tools that we develop. And this is something that we should be aware of. So all you can do is you can minimize the chances of errors occurring. You can minimize the effect that they have if they are made, and you can make them easy to detect and easy to reverse. Oftentimes that means having undo available. It also really, really helps, and it's a total eye-opener if you watch people using your system, including all the slips and mistakes, and you don't immediately correct them. It's painful, but it's very healthy to watch and very educational. I know a person who worked at Microsoft in the usability department back when this wasn't really a big thing yet. And she said her biggest success was when she forced engineers to watch movies in which users were making errors, right? In which users were just using their software and they made mistakes, and the engineers had no way to correct them. They had to just watch the user suffer through this mistake. So that's really something that that is important to realize. Watching people is incredibly helpful in this case. Whatever you do, don't punish people for the mistakes they make, and don't ignore the fact that they make a mistake. So make it quick for people to recover from any mistakes. We'll talk about error handling more later on in this lecture, in this class. Understand that people will ignore warning signals usually, and they will typically bypass warning features if they're inconvenient, like the type in the letters in backwards and people might get to the palindrome solution. So this is not a good error dialog. This is one that I actually got on my Mac at one point. So what's this telling me? Okay, the operation could not be completed. And it really could not be completed because could is written in capital with a capital C. And if in case I have any questions about this mistake, there's a helpful detail about client minus error minus not minus possible. Great, that's really helpful. If there hadn't been a printer icon on this dialog, I wouldn't have had any idea what is going on in the first place, right? So that's not how you do error dialogues. They should help users recover from their mistakes. Here's another one that I love from a software image burn on Windows, where the user apparently selected the CUE file and not the right one. And it's like, I'll do it for you automatically this time, but don't do it again. You know? That's not nice, right? Don't do that. All right. With that, we're at the end of this section of the class. We're done for today. Thanks everybody for tuning in and participating, and I'll see you again next time.
This content was provided by RWTH Aachen University.